Hello, welcome to my virtual laboratory and today's revision video on atomic structure. In this video, we will look at the following. We're going to review the definition of atoms and elements. We're going to investigate the three subatomic particles of which all atoms are made. We're going to use atomic number and proton number to work out the total number of each of those particles inside any atom. And we're going to learn how to arrange electrons inside an atom. Never trust an atom, they make up everything. Everything, all matter, is made up of one or more atoms of different sorts. There are about 100 different types of atoms which occur naturally and 118 elements in total that we know about. Each different sort of atom is called an element, and later in the video we'll learn what differentiates one atom from another. Atoms themselves are made of smaller particles called subatomic particles, and if you want to learn how we discovered about those, you want to watch the video on the history of atomic structure. There are three particles which make up an atom: the proton, the neutron, and the electron, and we'll look at all of these in the video. This table that you're looking at now is really important, and you should memorize the information in there. Each particle, protons, neutrons, and electrons, have a relative charge and a relative mass. Protons have a charge of +1 and a relative mass of 1. Neutrons are neutral. They have no overall charge, but they do have a mass of 1, and electrons, unlike protons, have a charge of -1. They're also really small. Their mass is thought to be around about 1/2000th of the mass of a proton. If you're asked to fill in a table including these values, you can write negligible, very small, 0 if you're lucky, or, if you can remember it, 1/2000. Protons and neutrons are sometimes called nucleons because they make up the nucleus of each atom. The nucleus is the center part of all atoms. Surrounding the nucleus are the electrons, which exist in regions that we call energy levels or shells. There are rules about how many electrons can exist in each shell away from the nucleus. The first shell, which is closest to the nucleus, can contain only 2 electrons in total. This is it here. After that, the shell hasn't got enough room to hold any more electrons, and so therefore we say it's full. If we have an atom with more than 2 electrons in it, then the next lot of electrons need to go on shell number 2. That's the next one out, and shell number 2 is slightly bigger. That means that it can hold up to 8 electrons in total. Shell number 3 also can hold up to 8 electrons in total. Before we need to start filling out the next available shell, shell number 4, not drawn in this diagram, can hold up to 18 electrons, although you will only ever be expected to draw a total number of electrons of 20 in an atom, and so therefore you don't really need to remember this number. If you want to make things a little easier on yourself, remember 2, 8, 8, 8. So apart from the first shell, which can only hold 2, all of the other shells hold a total of 8, at least as far as we need to worry about. You are expected to be able to work out how many protons, neutrons, and electrons are found in any given atom, and the periodic table of elements is the place that you need to go to, because it holds much more information than just the element name and its symbol. For example, as well as listing all known elements, the periodic table also lists 2 numbers besides each element. The mass number is the larger of the two numbers and the atomic number the smaller. Different periodic tables arrange these numbers differently, so always remember that the smaller number is the atomic number, the larger number is the mass number. You will need both when doing GCSE calculations. The mass number gives us the total number of protons plus neutrons. Remember, protons and neutrons both have a mass of 1. So they contribute nearly all of the mass of any element. Magnesium has a mass of 26. It has a certain number of protons and a certain number of neutrons, which add up to a total of 26. How many protons? Well, that is told to us by the atomic number. The atomic number always tells us the total number of protons. Now, sometimes you might be asked to work out the total number of neutrons from an element given that information. Now, if the mass number is the total number of protons plus neutrons, and the atomic number is the total number of protons, then surely all you need to remember to do is to take the atomic number away from the mass number, and whatever's left will be the number of neutrons in your particular atom. Why do we sometimes need to calculate this? Because not every atom of magnesium will contain exactly the same number of neutrons. So the answer to that question is we use the periodic table of elements. Protons are given to us by the atomic number. Neutrons is the mass number minus the atomic number. And to work out the number of electrons in an atom, the number of electrons is always going to be the same as the number of protons. That phrase "in an atom" is important because there are things that look like atoms which don't have the same number of electrons and protons, but we will look at those in another video looking at ions and isotopes. So to sum all that information up, I can use the information from the periodic table of elements to draw out an atom if I should want to. Now I'm going to draw out the whole thing, including the nucleus. Most of the time you wouldn't be expected to, but I'm going to do it and show you exactly how you can draw these things to make sense to an examiner. Okay, so an atom of magnesium has got 12 protons inside it. Okay, so we can show that by drawing 12 of these dots. Now to make a difference between protons and neutrons, it's probably best to draw a little plus inside each of these. 6, 7, 8, 9, 10, 11, 12. Now, to draw my neutrons, I'm going to use something else. You might just draw a hollow sphere. I'm going to change colour as well. Now, 26 minus 12 is 14. So I'm going to draw 14 neutrons in and around my protons. There we go. And now for the electrons. Obviously in real life the electrons would be much, much further away from our nucleus than this, but we've only got a small amount of space and we're just trying to show an examiner what we understand. Now if I've got 12 protons, I've also got 12 electrons, and they exist in these shells or orbits. If you're asked to draw a diagram, it helps to draw little dotted lines to represent these shells. So it's not a perfect circle. I'm going to draw 2. I know I'll probably need more. Okay, and in each of those I'm going to draw my electrons. Now you can do it in all different sorts of ways. I'm going to use crosses to represent the electrons. So the first shell can hold 2 electrons. I'm going to put one there and one at the bottom. It doesn't really matter how you draw them, but I tend to prefer to either put them in pairs or separate them as far apart as possible. Okay, so that's 2 out of my 12. So I know that shell number 2 can hold a total of 8, and I've certainly got more than 8 left, so I'm going to draw these in. And to keep things neat, I'm going to draw my electrons in pairs, but each pair I'm going to space around my atom. You don't have to do this, but I do find that it helps eventually. Now then, that is 2 electrons in the first shell, 8 electrons in the second, so that is a total of 10. I've got 2 electrons left because I have 12 in total, so I need a third shell in order for those to fit. So I'm going to draw that. Oops, not very good there. And I'm going to draw my final 2 electrons, just showing them nice and clearly, and I'm going to separate them like that. Okay, that is a total of 12 electrons. Now there's also a way that you can write this called the Electron Configuration. That, rather than using a diagram to represent this, is a different way of using numbers only. But there's a special sort of chemistry code in order for us to understand it. And that is a list of the total number of electrons in each shell, with each different shell shown by a comma. So we've got 2 electrons in the first one, followed by a comma, 8 electrons in the second shell, followed by a comma, and finally 2 more electrons in the outermost filled shell. So the electron configuration of that diagram is 2, 8, 2. So now you know what particles make up atoms and how to draw them in a structure.